Hey everyone, it's Danielle again. Today we're gonna do some more Python. How has everyone's workshops been going? I got some new stuff to show you all today. So this is Colin. His name actually is Colin because it says so on his little tag right here. However, he has an N on him for some reason, and I accidentally drew on him a Sharpie. And I also have this new one that was made by my coworker. This is a 3D printed dragon. It's really cool. It feels really nice. It's super flexible. I'm gonna name him Kyle. This one's so cool, right? Yeah, so everyone tell me about your workshops. What workshops did you enjoy today? What's been the highlight of your day? And if you're just logging on and this is your first workshop of the day, then glad to see you all here. Thank you so much for coming, and I'm glad you can join me. Ooh. This one's really nice too because I can like wrap it around my arm and wrap it around my arm like a little parrot. You see? And he just kind of stays there. Hi, Adam. Yeah, feel free to drop a hi in the chat. So I'm worried that this workshop might take a little bit too long. So I'm going to try to jump into this a little bit quicker and just get straight in. But first, let me give you all some links. I did not prepare the links at a time. But first, let me drop the check-in link. I'll give you all a chance to check in with that. But make sure you're checking in here. And let me just pull up one more thing. Then we can get started. Okay, cool. Let's get going. Okay, so I'm going to share my screen. Share my full window. And where to start? So, if you need, just in case you haven't done this before, we're going to be using VS Code as our IDE. Drop it in the chat if you need time to download VS Code. I'm going under the impression you all have basic Python knowledge or basic programming knowledge. If that's not true, feel free to let me know and I can totally adjust for that. And I forgot my water again. Let's see. I actually do have water here. Ooh. I've been coughing a lot when I've been streaming lately. Just like talking is drying out my throat. But this is gonna be my last workshop of the event. So sad. Boo-hoo, but I'm glad you all could join me for it. Okay, so you should have an IDE downloaded, any sort of IDE. I'm going to be using VS Code, and you should also have Python downloaded. Some other things that you should do is blah, blah, blah. You need to import Pygame and all that jazz, and I can go over this in case you've never done any Pygame-ish before. But we can go, since I think this one's going to run a little long, let's just go straight into the basis of this. So the first thing you're going to do once you have a Python file opened up is you're going to import your Pygame. So now, if you haven't done Pygame before, you're definitely going to need to do an npm like install or just like just a pip install Pygame. Just like that before we begin, and I can drop this command in the chat. If you don't have pip installed already, or if you don't have Python installed already, let me know, and then we can do a little pause and wait for all of that. But then that's the command to install Pygame. So all you would do is type pip install Pygame. It might not work in this terminal, but yeah, because I don't have pip installed in this terminal. But if I did have pip installed, then that would work right there. Okay, let me know if we need some more time on this. And then in the meantime, I'm going to just go over some very basic screen setups for a normal Pygame game. And I have a template for this all, so if you're like still catching up with all the installation stuff, I can just send you the template at the end. Someone notes for Linux, do pip3 install Pygame. I actually think that's what I need on my computer. I think this computer is a pip3 install Pygame. Hello, Way. Hello, RPJ. Hello, H14K. Nice to see some returning faces. Okay. So I'm gonna show you all how to do a basic template, and then I'll send you a template that I have uploaded to my GitHub for an old version, so you all can download that. But first of all, of course, you need to import Pygame because Pygame's a library that we're gonna be using, and doing this will give you access to all the Pygame functions. And then you always start everything off with a Pygame init, just like that. That's how you initialize your Pygame. So these are just like the bare essentials for what you need for a Pygame. This isn't for the game. And then you're going to have to actually do something to set up your drawing window, which for that you're going to save in some sort of variable pygame.display.set_mode, and then you're going to have to put in your screen size. So this first variable here is going to be your x-axis. The second one here is going to be your y-axis, and I can play around with that if we have time and show you all how that works. But again, these are just like the essentials you need for every single time you use Pygame. So there we have that. And then we can go into like, trust me on this one. So you're going to need to do this thing we'll call, you're going to have to create some function, and I can explain how this works. It's easier if I just explain after this is all done. And of course, if you need me to slow down on anything, let me know. I was just timing this event outside last night, and I was just like, wait, this actually takes me quite a bit of time to explain. But of course, it's all about like getting true learning. So if we don't get through the whole workshop, but people want to go over specific steps, I'd rather like go over those specific steps than like go through the full workshop and have everyone super confused. Okay. And again, I'm going to send you all this base code in a little bit. I just wanted to type it out while we're going over it all. Let me see. Is my text big enough? I'm going to zoom in a little more, make it more visible. You can see here what I'm doing is I'm importing Pygame. We do Pygame init, and I already said over here is the screen. And now, right now, we're making this while loop. So what's going to happen with like a Pygame file is we want to draw each individual screen. So like flip books, when you're flipping through a flip book, you have to draw every single individual screen and like individual drawing. And when you add them all together, it looks like something is moving. That's the kind of effect we're trying to recreate here. So this while loop is just pretty much going to be the effect of you flipping through all the different pages. And then what's going on in the while loop is going to be each individual picture. I like to think of things as like frames per second, where like this is like the whole running thing, and we're creating an individual frame that you're going to see inside of the while loop. So again, this is just setup. This is just like the basic things you're going to need to like get your game running. You're going to need this every single time. And then right here, we're going to fill in the actual content. So just for like filler, we're going to actually build a game later. But for filler for now, we're just going to fill this screen with plain white. So this is the RGB code for the color white. 255, 255, 255. And we're telling it to fill the full screen with that. And remember, we created the screen variable up here. And then let's just draw a simple circle so we can all just see that when the screen is filled in. And let's make this circle, I forgot. I think this will make a blue circle, It's yeah, RGB. This first is how much red you want, this is how much green you want, and this is how much blue you want. We're gonna fill it all 255 here to make it blue. But if you want it red, you can just put 255 here and 0 here. And then this we want it in the center of the screen, so we're just gonna put it at at the very center. This is the x-axis where we want it, and this is the y-axis, and I'll be able to demonstrate that once we have all the base code down. And then this is the either the diameter or the radius of the circle. I can never remember. But I tend to just make up the numbers and like see if it feels right. And then the last thing you need to do for all of this is to do this line right here, pygame.display.update, and then that's going to actually make everything that you drew right here, like you drew this and you drew these two, that's going to make it actually display. And at the end, we always want to do a quick pygame.quit so the user can get rid of the screen whenever the while loop's finished running. So when we run that code, that's what we should see, a blue circle in the center of the screen. And like I said, for those that were trying to make the screen, who were trying to download everything before, I'm going to send you all some template code real quick. So in case you weren't able to follow along there. So here is a random GitHub file I have that happens to have template code from like my Global Hack Week share. And we have some questions in the chat. Way's asking, how do you control FPS when using a while loop? So I don't think you actually can control your FPS. Like if you're asking, like, can you make it run faster or slower? Like for this version, I don't think you can. That's why sometimes you'll see some lag when using Pygame. I'm sure if we did like some complex things, we can make it more controlled and like actually like have consistent FPS. But you will notice, at least like probably on my screen since I'm streaming, that there sometimes you'll get like some elasticity from the FPS not constantly being consistent. And for this question, are you using GUI to make the game? Using a GUI. So we're going to be using Pygame we're going to be using Pygame to display everything. Yeah, but I'll see if I can point out like how, like when I was practicing it last night, like something you'll notice is that when the pipes were moving across the screen, sometimes they would slow down a little bit just because like can't get the timing exactly right with the while loop. So yeah, this is the link right here. And that if you click on that, that should bring you to my template code, which I'll show you right here. And then that's just a copy of everything that I wrote now for everyone who was busy downloading stuff. And again, all of this code, like feel free to keep this link and use it whenever you want to do a Pygame. It's just this is all the code that you need for just very basic Pygame stuff. Of course, you don't need any of this actual content. I mean, you need a screen fill of some color, but you don't need this circle or anything. The circle is just to demonstrate how that would work. Okay. Let me know if anyone's still busy getting set up. I want to highlight Kyle one more time for anyone who missed him. This is my new friend Kyle. He's quite long. He is as long as my entire arm, which is really cool. One of my coworkers makes these in their website. They actually sell them as well. And I think they're so super cool looking. Like this, just the amount of detail in the tail alone is quite insane. Okay, nobody's told me to wait, so I'm going to assume that everyone is set up and ready. So let's go ahead and get started. So looking at the elements we have on the screen now. So we just have this blue circle. So my plan for this is I want to use three classes. I want to use a pipe class to make one of the pipes, just one. But then I want to use a pipe pair class to pair the top and the bottom pipes. Again, if you don't feel like copying exactly the code I'm doing and you want to do some exploration on your own, or maybe even try using like a different language or something like that, feel free. But if you're following along with me, the plan here is to create one class to control just drawing like one green pipe, and then the other class pairs the two pipes together, a top pipe and a bottom pipe. So it'd be easier to visualize as we go on. But you know how like for oh wait, I should probably demonstrate what Flappy Bird looks like. Let me look this. Does anyone not know what Flappy Bird is before coming to this workshop? I kind of went under the impression that everyone would know, but I realize that I probably should not have. So this is Flappy Bird. So you can see while I'm playing, there's two pipes. One comes from the top and the bottom, and the user's goal is to go in between the two pipes. So I want to make the top pipe like just like a pipe class to control one half of the pipes, and then another class to like help the top pipe and the bottom pipe move together. And then the bird itself will be a class, of course. None of this really needs to be a separate class. I just feel like classes make everything cleaner and everything. Adam, this is Kyle. This is my new friend Kyle. See, he's a dragon, a wingless dragon. Throw some respect on my friend Kyle here. He's joining us in replacement of Blahaj today, along with Colin. This is Colin. Brand new things for me to sit next to and constantly reference when I'm doing things. So, let's get to the next thing. So, yeah, let's start with how about we just start with the pipes? Because we can do the pipes and then just the simple movement of the pipes. And then after the pipes are working fully, let's get the bird into the game as well. So, let me get all set up here. Right, I want to fix up my screen. Okay. So, let's start with our basic pipe class. So I'll go a little more in depth into how to do classes because I feel like Python is a very beginner language and you can get away with doing a lot in Python without having to know the class structure. So you build a Python class like this. So this is how you build a Python class. You would just that's just the formula for starting it, and then you to do your constructor, it would look like this: underscore underscore init underscore underscore, and you pass self in the parentheses. You don't need this return none here. That was just part of like how it initializes everything. So thinking about like what information we would need for a pipe. So real quick, let's go over how you would draw a rectangle in. So wait, before I do this, let me show you how you would just draw a rectangle on the screen because I drew a circle and I showed you how to draw a circle, but I never told you how to draw a rectangle, and that's kind of important to know before we continue. But what you would do is with the same beginning, pygame.draw, but instead of circle, you would write rect, and then you would need to pass in the screen as the first argument, which is this right here, just what you want to display on. Then whatever color you would want. So the color I picked out for this one is this. I think that this is like the least amount of like eye ruining green that you can choose. but choose whatever green you want and feel free to like just do random orange pipes if you really want to. And then for the third argument, you're going to need to pass the information for where you want the rectangle to be drawn. So you're going to do Pygame, and to do that, you would do Pygame dot rect uppercase R, and then you're going to have to pass in these variables: an x-axis, a y-axis, and then you're going to have to put in the width and the height. So just for now, let's just put in a random like x of like 50, 50. Let's set the x to 50 and then the y to 100, just so we can see a big 300. So we see a big difference there. And then let's do a width of, let's say 75, I think would be a good number. And then let's make the height of the pipe. Uh, let's start with 500. So now you can see like at x-axis 50, which would be right at this point, and at y-axis, I think we put in 300. That would be, so 0, 0 is this top left corner of the screen right here. So for x-axis, it went here, right here is x50, and then down here is x300. So the starting point of this rectangle of where it was drawn was right here. This would be 5300. So now we're able to draw this little rectangle on the screen. And I'm also going to erase this circle because we do not need this circle. And if you're wondering, like, if you would like to change the size of your screen a little bit, maybe make it more mobile app-like, something you can do is this is actually choosing like your width, and then this is the height of your screen. So if you wanted the width to be super thin, you can do 300, and then you can make it higher, like 800, and run that. And you'll see the screen looks totally different because this is now using 300 on the x-axis and 800 on the y-axis. But I like to use 800, 600 because I think it looks clean and it gives us plenty of room to work with. But this is the code for just writing a general rectangle. I'm actually going to make this terminal smaller because we don't really need it unless there's errors. But now you can see all of the information you need. So when writing this class, we need this pipe class. And again, we're just creating the top pipe right now. We're not making the pipe pair, just the top pipe. We can see something we might need is the width and the height, of course. So let's type that in. We need self.width equals and self.height equals. And let's set the width and the height to what we have now, 75. I think we have 400. Here, let me see what numbers I used when I was practicing. I used 7,400 because these are the numbers that I found to fit the screen the best, at least my screen size. And then let's set and then we want to give it an X and a Y axis. So for now, let's do self.x equals, we'll keep it at the same thing as we did before because we can fix this up later, and x.y equals 300. And that is enough for now. And let me stop drawing this. So now when we draw it, it's just going to be an empty screen because we're currently not drawing anything. Because instead of drawing it inside of here in the while loop, I want to draw it using the class. So I want to make a define draw class. Any form of function you make into a class in Python, you're going to want to include self. That's just a requirement to pass, but when you're calling the function, you don't have to type self in. But if you wanted to include extra parameters, you would just include them right here, like self.x. And then when you're calling the function, you would just call draw and then put whatever you wanted to fill in for parameter x. And we'll expose you all to that later if you haven't already. But in this draw function, that's where we're actually going to want to draw the rectangle. So let's choose our color out. I told you before that I like this color because it doesn't completely bust my eyes like a neon green would. And then we're just going to repeat that function that I explained to you before on how to draw a rectangle. So pygame.draw.rect. Then we're going to put in our screen as the first variable. Second variable is going to be the color. And then the third variable is going to be that pygame dot, what is it, pygame dot rect again? Pygame dot rect. And of course, that has four variables that it needs. It needs the x-axis, so we're going to do self.x. It needs the y-axis, so we're going to do self.y. Then it needs the width, so we're going to do self.width. And finally, it needs the height, so we're going to do self.height. So right there, I'm going to leave this on the screen for a few seconds so everyone can see it and follow along. But we have the draw function, the color, and then we have everything filled in. So I'm going to let that sit for a few seconds so everyone can follow along. Hello to Pawar Speaks. How are you doing? Adam's asking how am I doing today? Well, this week I've actually been pretty burnt out from all these like workshops and actually like doing my full-time work. But this is my last workshop and it's my favorite workshop of the week. So I would say I'm doing pretty well with that. Okay. So unless I have any objections, I'll go ahead and move on from now. And of course, we'll take our mid-session break and like 30 minutes where I'll allow you all to like take a look at whatever you missed. So now we have two functions, which is just the constructor, and then we have the draw function. So we're going to hold all the variables we need to hold are going to be right here. So right here is where we're going to do all the variables. So then for that, we're going to actually construct one of the pipes by calling the pipe class, and we're going to name this pipe 1 pipe. So this is how you call the function, and it doesn't take in any parameters. So to create a pipe, what we would need to do is this. But that's not enough to display it because we actually have to draw the pipe now. So in Pygame, every single time you draw something, make sure you're doing it inside of the while loop. So now in the actual content, we're going to do pipe1 dot draw. And then this should draw our pipe on the screen in the same place as we expect it to be. And there it is right there. So it looks like everything is working correctly. Okay. So now, where should I go next? So how about now let's make the pipe actually move. Let's see. Yeah, let's do that. So let's move our x-axis to the other side of the screen. So our x range is from 0 to 800. Let's make it 700. So when we rerun it, it's going to be over on the other side of the screen. And then so then let's make it move by drawing a new function here behind the define draw function. Let's define move. Let's make this a brand new function. So moving is really simple. All we need to do is, so again, like going over how this while loop is working, what we're doing is every single time we do screen.fill, we are completely like covering up all the work that we did after this. And we're drawing a brand new item. And I can demonstrate this better if I can show it. But so the idea here is to move like your x. If we could just do self.x minus equals 1, And what that's going to do is every single time the while loop runs, we're going to move the green column to the left one, because right now it's at coordinate 700, and then at the next tick it's going to be at coordinate 699, then 698, then 697. So if we call this move function after we draw the pipe, what this is going to do is move the pipe to the left side of the screen. And to show clear what we're demonstrating, I'm going to get rid of this line of the code, which is, again, just painting the entire screen over white at the beginning of every single run of the while loop. And you'll see if I run it without that, it's actually just showing that it's just redrawing it over and over and over again every single second. So that's why we need the screen.fill. Okay. So there we go. We have one pipe moving to the left. And that's just one pipe. And now we need two pipes. But the big thing here that makes Flappy Bird kind of complicated is that we need a pipe on the top and a pipe on the bottom, and they need to be moving together with with like enough distance in between the two pipes for the bird to actually go through. So that's why I was thinking we can create a pipe pair class to take care of all that work for us. Because if we try to just create a big list of multiple different pipes, it's going to get super chaotic. We're not going to be able to manage it. So let's create another class, and let's name this class pipe pair object. And all classes need a constructor, so let's make our underscore underscore init function. Get rid of that return statement that we don't need. Get rid of this pass. And for this, let's create, instead of creating the pipe pairs right here where I have pipe 1 equals pipe, instead, let's get rid of all the pipe 1 code, and let's take care of it inside of this pipe pair class. So let's do self.topPipe equals pipe x comma y, because we need an x-axis and y-axis. Okay, hold on. I need to explain this. So we're going to make a top pipe, and we're going to make a bottom pipe. But the problem with just like doing it like this is that now these two pipes are going to be on the exact same part of the screen. And so we need to have some way that we can change the Y on the bottom pike, so it's not just being painted directly over the top pike. Like, we need to have some more control on where the placement of the pipes are going to be. So to take control of that, we're going to add two parameters in this function here. We're going to add an X and a Y. And with this X and Y, we're going to be able to decide where everything's going to be placed. And instead of hard coding in 700 and 300 here, we're going to allow ourselves to type in X and Y. So we have pipe 1. Let's put in our X as 700 and 300, I think is what we had before. So it's all the way on the right of the screen and 300 down. But we want this to be the top pipe actually, so let's just set this to 0. And for the bottom pipe, we want it to have the same x-axis, but we want it to be much further down. Let's try 700, 0, and 700, 400. Let's see how that goes. But of course, if we run it, since we never actually draw it anymore, it's just going to be a white screen. So again, we're going to need our draw function. Oops, let's not do that. So define our draw function. And simply, we just have to do self.topPipe.draw. And it should just know what to do because we are just accessing this draw function that we have already written down here. So then let's do it again, self.bottomPipe.draw. And let's run this code to see how it looks. We never call the function, so of course it's not going to show anything. Go back to our old variable section. We actually need to write a pipe pair. We need to call the function. So let's type in pipe pair here so we can actually access that. And then down in the actual function, let's do pipe pair. Is that what I called it? Oh, I just call it pair. We're going to need to do pair dot draw. Now, they are drawing both the pairs. It's just they're so big that they're drawing as just one giant one. So what we're going to need to do here is just space them out a little more. So let's, instead of drawing them at 0, 400, let's draw them at 0, let's try 0, 600. See how that looks? Oops, shoot. Hold on. Make sure you're closing it out with this back X every single time, otherwise VS Code gets a little glitchy. But okay, so now the top pipe is here. The bottom one is way too far down for us to see it. So let's try 500. There. Now we have a little gap in this up here. Honestly think that this gap is a little bit too small. So I'm going to set this from 0 to negative 100. Make it a little bigger. All I'm doing is I'm spacing it out a lot. Because again, like I told you all before, the coordinates that we're referring to when we're setting the coordinates for the pipe, it's going to be the top left corner of the pipe. So the top left corner of the pipe is way up here, negative 100 on the y-axis. So the top of the pipe is over here. It's just that the height of the pipe is so long, it's going all the way down to the bottom of the screen. And I feel like this is a much more reasonable amount of room. I mean, you can make it smaller, make it Flappy Bird hard mode, but for the sake of like this, I'm not going to make it so big. Now we have a pipe pair. Now let's make it move together. So we've already told the pipes how to move. Now to make it move together, let's do a move function for the pipe pair. So let's do same as what we did with the draw. Let's just individually tell both of the pipes to move. So self.top_pipe.draw. Oh, not dot draw, dot move. And then we're going to do self.bottom_pipe.move. And then we actually need to write the pair.move function down here. Now we have two pipes that are moving together. Are there any questions on that before I go further? Colin? Any more questions? No? Why does Colin have an N on his stomach even though his name is Colin? Nobody knows. Okay, we have one comment. Type error, pipe init takes one positional argument, but 3 are given. So I'm just taking a guess on what this one could probably be. But my guess is, because I don't know where in your code exactly this is taking place. Wait, one positional argument, but 3 were given. Yeah, I have to guess which line of code we're taking in, but common problems that I've seen in the past are if your color isn't in, like for example, if you have color as an individual, like 50, comma, blah, 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 and it's not in the parentheses, that sometimes causes the problem. Also, just making sure you have your parameters listed here, like self, comma, x, comma, y. And then when you call it down, and then when you call it over here to include the correct parameters, like what I tend to see this with is just like incorrect parenthesis placement. is what I usually see this specific error for. Me showing the error for people who are coming from other streaming sources. Awesome. Okay, so missing parameters. Awesome that it's awesome that that was it. Okay, great. Easy fix. Adam wants cake. Go order yourself a cake. I cannot give that to you. Cool. Okay, so it looks like that's all we got. So now one problem you might see is the pipes after they finish moving across the screen, they just never come back. They're gone forever. And yeah, we can just like fill it in by like adding more and more pipes. But the problem with that is like once they're off the screen, it's like if we keep adding more and more pipe objects, eventually that's going to overload our system because there's going to be too many objects in existence and we're not even using 90% of them. So instead of just creating a brand new pipe, let's reuse the pipe we've already created by updating our move function. So, not this move function, the other move function. So we're going to say if the pipe is x-axis is less than -100, meaning if the pipe has moved past the left part of our screen, let's set the pipe's x to equal, our screen is 800, so we're going to set it to 900. So now if we run it again, then we should see that the top one's going to go across the screen, but the bottom one never comes back because it's still continuing on its normal path. And the top one should just keep going in a circle. So that's why we made this pipe pair class. We want an easy way to tell these things they need to stay together. We just want an easy way to like have these two constantly connected to each other. So instead of having to do some like complicated mumbo jumbo and like pairing and then like typing each name out manually, we can simply just say like if the first x is set to -100, let's just set the second's x to also equal 900. So now they're going to move as a pair. Wait till they get to the end of the screen. Yep, and there it is. Now they're moving as a pair. They're constantly going to be leaving the left side of the screen and coming back on the right side of the screen, which is perfect. That's exactly what we want. Now let's make more pipes. Woo! Because in Flappy Bird, it's not just one set of pipes going across the screen. You need multiple set of pipes. So to do that, we're simply just going to make, instead of a pair variable, we're going to make a pairs variable because we're going to put in multiple pairs into a list. Yay! So let's start with just two to keep things simple. Now we're going to have two pipes. But the thing is, so yeah, now we have pairs. We have to update everything down here because pair doesn't exist anymore. So instead of pair dot draw, we're going to say for pair in pairs. And we're going to say pair dot draw followed by pair dot move. So now that when we run it, we're still going to see only one set of pairs because, oh no, problem again. We can't customize where the x-axis is where the pair starts. So we're going to have to add some more flexibility. And how are we going to do that? Parameters. Another parameter added to our constructor. So let's allow ourselves to put an x-axis in for the pipe pairs. And now when we set up our pipe pairs, first of all, okay, let me go back. So we have pipe pairs, we just added an x parameter to our pipe pair. And what we're going to do now is we're going to make instead of starting it at 700, we're going to start it at X. And then we're going to start both the top and bottom part at whatever X parameter we put in. And then here we can place 700. And then here we can place 900. And let's rerun the code now with our X and 900. And now we can see 2 pairs of pipes. So it's as simple as that. And then both of the pairs keep returning, and they should constantly keep equal distance between each other, because as soon as they reach negative 100, they're going to move over. No earlier, no later. They're the same object moving at the constant speed, just one's lagged behind the other like a cannon. And we're actually going to start our first pair at 900 because I want to start it at the end of the screen. I did some calculations and figured out what looks the best. Let me figure out what I found out. Let me remember. Okay, so what I decided would be best is 3 pipe pairs um at this very weird space apart. So we're gonna do the first pipe pair at 1, 2, 5, 0, 900, then the other one's 1, 2, 5, 0. And again, you don't have to have these exact pipe pairings that I have. But I already did the what looks beautiful for you, and I decided that it looks beautiful like this. And I see a question in the chat, but I will get to in a second. But I did pipe pair 900, 1, 2, 5, 0, and 1600. And I feel like that makes everything really consistently spaced out like that. I feel like that's a comfortable amount of spaces, and it looks pretty constant. Like, I mean, that was kind of a weird spot, but yeah, I'm going to leave this code up on the screen for a second. So someone says their pipes are moving very fast for some reason. So to change the speed of your pipes, you're going to want to go to right here in our pipe class. We wrote move self speed minus equals 1. This means that we're moving the pipes to the left one pixel, I guess, every millisecond. If you want that slower, you can set that to 0.5, and that should move it even at half the speed that they're going now. And if you want that much faster, you can multiply it. So let's say like -2, and now they're moving much, much faster than they were before. So this is the number that's going to decide how fast. And if we move them at 100, then you can see they're just shooting like crazy now. I think 1's the best number for me, but you all can decide whatever number you want to play with. If you want to do super slow so that you don't have to try to actually win the challenge, feel free. But if you are like a pro at Flappy Bird, maybe try -1 million. I don't know. Okay, so now we have, as a recap, now we have like multiple consistently placed pipes running around over and over again. Next problem we have with these pipes, we'll solve one more. We'll just fix our pipes up, and then we'll go into a break period where we all can like get some water and stuff. But the last problem we have is this isn't a very interesting game because the pipe spacing is at the same area every time. So when the bird's flapping, it just has to consistently fly straight. So let's make it so the pipes are differently placed. So the big problem here is we don't want the pipe spacing to ever change. We always want it to be exactly this amount of space in between each pipe. So we need to connect our pipes again. And that's why we have a pipe pair class. So to do that, what we're going to do is so we're going to use import random to make this random. So first I'm going to do it without pairing the pipes together so you can see what the problem is here, and then I can show you all how to pair your pipes together. So let's start with randomizing the Y. Let's see. So first of all, let's have so right here, let's go to self dot top pipe dot Y. And we want to set that equal to a random number. And how you get a random number in Python is going to be random dot r in range. And then you put in your range. I kind of calculated the best range in my opinion, and let me look that up. I said the best range is going to be -350 and 0 for the numbers we picked, but you can play around with that and figure out exactly what number works best for you. So now when we rerun it, give it a second and you'll see what it happens. It's going to be all consistent until they get to the other side of the screen. But now you can see the pipes are coming in at a more random amount, but the bottom pipe isn't moving. And even if we just set the bottom pipe to another random variable, like let's say like to fix this, we do self dot bottom pipe dot y equals random between the range of, what did we do for the x? It's 500, between the range of 500 and 800. Then what you're going to see from that is that everything will just be, sorry, this is going too slow for my demonstration purposes, so I'm going to set the move speed to just to get things a little faster. But what you're going to see once they start randomizing is that things will never be like it's again still not consistent distances between everything. Like the game doesn't look good. So let's make these into a pair. So the space between our two pipes at this current point, we determine the best spacing. I guess it looks like 500 minus -100, 600. So what we're going to do is we're going to set bottom pipe y to top pipe y minus or plus 600. So for example, if top pipes at y is -100 plus 600 would mean bottom pipes y would be 500. So when we rerun that and we get through the first three ones that are the same every time, it actually is randomizing it. Those first two and like these two right here were just similar by coincidence, believe it or not. But you'll see like it truly is random because if you let it keep going, like you'll see it gets all the proper spacing. So that all looks good. But as we keep seeing, the first three are always the exact same. So to fix that, let's just copy our random function. And instead of doing -100, we're again going to replace that with the random number. So just the same type of stuff we had before. So then when we rerun it, and I'll rerun it down here so people can see the code I wrote. Wait, I didn't see the first three. I want to make sure it's right. Yeah, that's looking right. So now we have randomized pipes running. Okay, so I'm going to go ahead and call this time for the stretching break. If anyone has any questions, feel free to drop them in the chat. I'm going to refill my water as I always do. Drop your questions in the chat and I'll answer them when I get back and we can go into stretching break. And I'll leave my code up on the screen for you all to see. I'll leave the pipe pair code up. Adam, we always have time for stretching. What? You can't always fight me on stretching and water every single time. I'm trying to think what's best for your all's health. I will make sure my stream viewers always have the best of health. Okay, I'll be right back. I'll see you all in, let's say, 2 minutes. Welcome back, everyone. It's time for the mid-session stretch. Also, I don't see any questions, so I'm going to keep the pipe pair code up. If you want me to switch to a different portion of the code, just type in the chat and I can switch to that real quick. But it's time for the stretch. Everyone, arms up, wiggle the legs. I didn't get to show you all this stream, but I got this thing from the thrift store. It's like a floor bike. I put it on my floor. I put it on my floor, and I can just bike under my table while I'm doing my code and everything. And it's like exercise. And I don't even have to stand up. I wanted to get like an under the desk treadmill because I have a standing desk and I really like walking and stuff while I'm coding, but I can't really do that. But hold on. Yeah, I'm biking and you all can't even see me biking. Woot woot. But arms up, stretch over the shoulders. Adam, stretching will. Yeah, I am sitting right now. Jeez. Stretching will help you think better for whatever form you're filling up and for whatever reason. Now you all get a new angle in my room. Stretching time. Hands up over the shoulder. Touch your toes. All that. I got out of my chair to get my water, and that's pretty stretch like. Okay. Who's ready to get back to some code? I may be sitting, but at least I'm biking. Oof. Okay. Let's get to it. So, we have our pipes running. Now we need to make a bird, and we need to make this bird collide with the pipes. Someone asked a question in the chat, how long did it take you to truly begin to understand how coding and programming works? So this is a really cool question. I didn't start programming until my second semester of college, and I started on Python because Python's a good place to start with because there's a lot of like no simple class structure. Like, I mean, this class structure is pretty simple. Like, you don't need classes to, you can just do normal functions and while loops. And I mean, I had a pretty easy time learning it in class, but I also feel like there's so many good tutorials that you don't really need a formal education on anything. Like, you really can learn how to code well with just like simple beginner Python YouTube videos. And I feel like coding for me just kind of made sense in my brain. I know for some other people it's like you have to work harder, but like it's triggers the part of my brain that just comes naturally to me. So I feel like it was just a really good fit and a way better fit than biology. I was a biology major before that, and let me tell you, my test scores, no matter how long I studied, was nowhere near as good. And it felt good to like just really be good at something. And programming felt like really natural and just kind of made sense to me. So that's why I really liked it, and that's why I always do so many like workshops in Python because it was just my starter point. And I feel like it's really good for because with these workshops you never know how much experience anyone has, and Python's like a really good way to like we can easily explain that to someone who's just starting. So that's why I like it. But let's make this bird. So remember the circle code from before? We got to bring the circle code back. But as I said before, I like putting things in classes because classes keep things clean. So let's make a class. So let's make a class called bird. And of course, we need to initialize this class the same way we always do. With some self. And then as you can see from like these other things, what's really going to be helpful here is having self.x. I'm going to cough. Okay. I was holding in that cough for like the past minute. So, and I was trying really not to do it because I hate muting my mic. It takes so long. But ooh, self.x, and I'm gonna just set this randomly to self to 100 and 250 for the x and y axes, just because the bird could really start anywhere. And then, as you remember before, another thing that's important with circles is we need to set the radius. I'm randomly setting this to 25. You don't really need it in the construction class. You can kind of just, as a matter of fact, let's not put it in the construction class. It doesn't need to be here. We can just hard code it into the draw function because we're only ever going to include one bird. So the class here, since we're only ever making one bird, is kind of more flexible. Like we can do all this stuff inside of the while loop just as well. I just think it's good practice to put everything in classes. And then we need to do a draw function just like we did with the pipes. And the color I chose for the bird, I actually went through several color choices. But the color choice I'm going with is 240, 230, and 140. So, and then this is just like a really nice pastel yellow. I strongly prefer this one. So now let's pull out that draw circle function that you saw in the template. And drawing a circle is really similar to drawing a rectangle. You start with a screen, and then you need to add the color just like we did over here. And then we need to we need to include where we want it on the x and y axis. So we're going to have to make this as a coordinate. So don't forget your parentheses here. Otherwise, you're going to get some like improper amount of parameters error. So we're going to have a parentheses, and inside of those parentheses, we're going to have our self.x and our self.y. And then outside of the parentheses, we want to have we want to have the radius, which we're just going to make, I think I said 75 would be a good number for this. Oh, 25. 75 is way too big. So yeah, again, make sure that the self.x and the self.y are inside parentheses because we need to have them as one parameter. And then we, of course, need to actually draw it again. Always forget to draw it. But after this for pair and pairs function, let's just do bird. Oh, wait, we need to create the bird. Under all the variables, let's make bird equal to bird constructor class. And then right here, just type bird dot draw. When you run that code, there's your bird. He's a little bitty baby. Just the yellow circle. You can actually add images in Pygame. I don't think we're gonna have time for this in this workshop because I timed it out and it doesn't seem like it. But you could totally feel free to stay after and do some more imaging stuff if you want to. And it would look a lot prettier if you put in like column images or stuff like that. But we're not gonna do that right now. So now the hardest part, I think, for this is going to be getting the movement down for the bird. So I've kind of simplified this. Like, let's just actually just go into making some basic movement stuff now. It's just kind of hard to make the bird movement look smooth. I created like a simple version of bird movement that I think will look good. But the main idea with the Flappy Bird movement is that we want him to shoot up and then slowly come down. So to get keyboard input in Pygame, this is another fun thing to learn. So I'm going to create another section here called Get Keyboard Input just to keep everything clean. And to get keyboard input, you're going to want to type this function right here. It's save it in some variable. I'm going to save it in key input. Then you're going to do pygame.key.get underscore pressed. So this just means we're using Pygame to figure out what button the user is pressing. So then, after we know what button the user is pressing, we can do if key underscore input, the variable we created. And then we take index pygame.k K underscore up. Then we're gonna do bird dot y minus equals 1, which to explain this code, it's saying like when the user presses the up key on their keyboard, we want the bird to move upwards. So now running our code, you can see I'm pressing the up button, the bird is moving upwards. But we also need a force of gravity pulling the bird downwards because we don't want the bird to always be able to move up. Let's see, where's the best place to put this? So I'm honestly thinking let's just put the bird movement in another function here. So it's completely separate from like the keyboard section and we can just keep like just those mentally in our head separately. So let's create a move function since we have one for everything else. And then let's just do self.y plus equals 1. And then let's call it here bird dot move. So this is actually going to be a problem because when you run the code, what you're going to realize is if you press the up key, that's just going to make the bird stop because we are consistently moving the bird down 1 pixel and up 1 pixel every image. So the bird will move down, but if I press the up key, it won't go. So we need one thing that we need to make sure is that the up is greater than the down. So let's just do plus let's just make the bird go up 3 pixels and then move down 1. So the bird is moving up net 2 pixels when the user presses the up key and net 1 pixel when no buttons are pressed. So now we got some basic movement happening with the keyboard presses and everything. Isn't that cool? No collision yet, but this is like truly the start to a game. It's now interactive. Any questions on keyboard presses before we go into more bird movement? Okay, I think we're good. So one thing you'll notice is when we run the code, the player can just go up and down as much as they want. Like they can go all the way to the top of the screen, and they like just never have to let go of the up button. And that's not very Flappy Bird, if you ask me, because the whole point of Flappy Bird is that the bird shoots up and then it floats down, and it needs to look flappy. It needs to look weird. So my idea on how to fix this like, there's several ways to do this, and if you can get it looking really smoothly, let me know, and I'll be super impressed. But my strategy that we're going to be using today, which I think is an easy strategy to teach, is the cooldown strategy, which just means the user can press the up button for X amount of time before they have to wait a cooldown period to press it again. A cooldown period is just amount of time that you have to wait before you can press the button a second time. So how do we do a cooldown period? Now that is the question. Um, so first of all, we need a cooldown variable. So we're going to write that here. Cooldown is going to equal 0. And we're going to do um we're going to do cooldown when the user presses the up key, cooldown is going to equal 30. But the catch is the user can only press the cooldown button if cooldown is less than 0. So when cooldown, so what's going to happen here is when the user tries to go up, let's print cooldown in the terminal so it makes it clear what's going on here. Expand this. Okay, you should be able to see the cooldown printed here. So right now the cooldown is 0. Um, one sec. So right now, the cooldown equals 0. If the key in Pygame is up and cooldown is less than 0, then the bird should be able to move up, and then we are automatically going to set cooldown to equal 30. Yes. Oh, and another thing here is we want to make sure. So, oh yeah, so what happened here with like how it was 0 and we were never able to go up? That was because cooldown, as soon as it was set to 30, this was never running anymore. So one thing we're going to need to do here is we're going to need to do cooldown minus equals 1. So once it does get set up to 30, it's going to actually be able to change at some point. Whew. But I think it's happening way too quickly for us to be able to handle. So instead of doing -3, we're going to do -60 because that's going to give us more shot. Let's do minus, I don't know exactly what number is going to be good here, but we're going to do -100. Okay, so now we can see with -100, I'm able to press the button and it shoots the bird up, but I can't consistently, like, it's kind of a flapping motion because you see I can't consistently just fly up. It has to flap up. Now we're gonna have to play around with these numbers a bit to like get it to look exactly right. You can increase your cooldown if you want. Like if you want the people to be like not able to flap very often, you can update this to 60. And you see like the rate in which I can shoot up takes is significantly different. Or even if this was 200, let's say, I think this is might be even too much to see. But I'm holding the up key right now, and I'm just going down because I can only go up every 200 ticks. But then, so the number that I ended up choosing was the bird goes up 60 and the cooldown is 30, meaning the after we shoot up 60 pixels when the user presses the up button, and then the user has to wait 30 screens before they can go up again. And I feel like that gives you like a good enough ability to play the game because you see now I can still get through all different these different pipes. Like I feel like that's just a good number to make the game actually playable and not too difficult. But again, if you want to make it the user jump less often, feel free to make this number larger. And if you want to make the bird shoot up higher, you can increase this number. And if you want to make the bird not shoot up as much, you can decrease this number right here. So play with those numbers and figure out whatever you would like. Do we have any questions on cooldowns and how that works? Everyone's game's looking good. Still, the problem here is we still can't lose the game. We're gonna have to do something about that. Going back into what we were talking about before, if you wanted to make the game harder by making the pipes move faster, then you can just increase this number right here, or decrease it if you want to make it easier. Okay, I'm gonna take out this print cooldown. So is everyone's cooldowns working? I feel like this is the most complicated concept to understand in this whole thing, so I wanted to make sure everyone has a good understanding before we move too far ahead. Okay, sweet. So let's make it so the game finishes. We're going to have to add collision detection. So, Pygame has an ability for you to see like if two coordinate points are colliding. It's not foolproof, so like if things like skim each other's corners, it tends to mess up sometimes and like let that slide. And you'll see what I mean when we actually get this code implemented. But it does have built-in stuff that we will be using today. So, this, let me remember what's the best way to do this. So we have so this is kind of complicated because we have a pipe pair, like we just have a lot of embedded pairings that we have to take into account for. So, and we have to make sure every single pipe is being looked at every single tick. So to do this, we're going to use this foreign pair and pairs section of our code that we've already written. And after the pipes move, what we're going to do is we're going to say for we're going to say for pipe in pair. That work? Let me remind ourselves. So our pair function is this. So for pipe, we're going to say for pair and pair. So for pair and pair is this individual thing. Mhm. And we want to say, but we don't want to access this paired object. We want to access this pipe object. Oh yeah, so then this is why we had to do a return statement right here with our draw, because we're gonna need to save some data. Let me take a second to like catch up before I just fill all your minds with loose information. Feel free to drop questions in the chat right now so I can remember this information. But I remember now. Okay. So you saw we did our draw function right here. We're gonna have to somehow save the information of each of the individual pipes. So how we're gonna do that is we're gonna have we're gonna actually return the information, because right here we return our rectangle information, and that's gonna give us just access to the item in Pygame's world. It's just gonna like give us access to this item and say like, hey, this exists and we want to do something to it. And one thing we can do with this item is like check collide points and everything. So make sure you're returning in your pipe object. Make sure you're returning what you draw here. And then we're also going to have to make sure we return what we draw in our pipe pair. So you're going to want to make another list. And we're going to, this draw function, we're going to make return a list of the top and the bottom pipes. So to go over that, make sure you are turning inside of your pipe object function. And make sure you're returning inside of your pipe pair. And what you're returning in your pipe pair should be a list of your top pipe and your bottom pipe. So then what that's going to do is make it so we can access that when we get over here for pair and pairs. So now when we do pair.draw, we can save the pair data right here. And then we can do for p and pair data. So, and I'm going to comment this code to make it clear because I know this is a complicated concept, but the pair data equals information on is wait, the pair data is going to be a list containing the data for the top pipe and bottom pipe. There. Pair data is a list containing the data for the top pipe and the bottom pipe. So when we're doing for P in pair data, we're actually saying for pipe in pair data. So then this is going to be accessing just the top pipe or just the bottom. So now we're going to take this pipe, and with this pipe, we can do if pipe dot collide point. Collide point is the function that we're going to be using to see if it's colliding. And we want to use bird.x and bird.y. So what this is doing is it's saying take just the top pipe and see if it's colliding with the bird's x-axis and y-axis. So it's like seeing the individual coordinate that the bird is at, and it's seeing if the pipe also exists at that coordinate. It's just seeing if the pipe and the bird exist in the same place at the same time. And if it does, we're going to make a new variable called game over, and we're going to set that to true. Did I explain that well enough? Or does anyone want me to go over that a second time? Feel free to type in the chat if you just want me to explain it a second time. Or if you don't want to ask now, feel free to ask in the Discord later. But the big thing here is if game over is true, then the game is over. And then we're going to have to make it actually be over. So let's create a function to do that. So if game over, then we want to type on the screen in big letters that the game is over. And doing typing on the screen is a little different than the other things. I'll just show you all the code for that. And it's just kind of code you have to know. There's no real logic or reason for anything. But you're going to set a font size. So this is just one of the fonts that I know exists. It's kind of the only font that I know exists in Pygame, so I use it for everything. But it's Free Sans Bold. Dropping it in. Adam says Discord party later. Maybe. It depends on when it is. I am in the mood to like hang out with people and talk to people, but sometimes I'm just too exhausted. But there is the font. And then you set your font size. Okay. Game over font. So now that you have your font, the next thing you have to do is you have to do text equals font dot render. And then let's just do game over in big letters. And let's set it to true. And then you also have to set a bunch of information about like the colors you want. So you can set a highlight color and you can set a text color. So this first color I'm setting is going to be the text color. And the second color I'm setting is going to be the highlight color. And then you're going to have to create this whole like rectangle for it. These are all just things you have to do to get text to appear. And then you have to set the location for it. So you do set the center equal to like the center of the screen, so 400, 300. And then to make it actually appear, the thing we're all looking forward to, it's screen dot built. And then you put in all the information that we just built. So text and text, comma, text game over. Then when you run that and we lose the game, it crashes because surface object has no attribute built. Hold on, I forgot something. I got this error yesterday. Let me think. What caused it? Text got no surface area. Surface object has no altitude. Hold on, I have to think. I can't remember what I did to cause this error, but I did this before. Built text game over, built. Give me 10 seconds to think about what this was. Pygame.surface object has no attribute. Or it's not built, it's blit, right? Yeah, it's blit. Okay, I just switched up the L and the I. Never mind, I didn't run into that. I just mistyped. Okay, it's blit. So now it should work. Yeah. So now whenever we run into something, the game over screen comes up. So everything's still moving, but that's just because you can manually pause everything. I think Pygame has a pause function on the screen, but also you could just like you can write another if statement here that says like if game over, if, or you can just put everything here into, hold on, let's move this up, everything. Sure. Let's move this game, if game over, to the very end of the screen. Okay, so all that's at the end of the screen. Uh, let's do an else here and put everything else outwards. Oh no. This all out. All the actual content moves out, and we say if game over equals false. False capitalized because this is Python. So if the game over equals false, run the game. Else, run game over. Let's see if I forgot to include anything in that. And also, by the way, you can I forgot to show it actually working. You see if I go through, everything's fine. But if I die, then everything stops on the screen and it's game over and we have to restart to play. So that's the basis of this. We have a few more minutes. If anyone has any questions, feel free to drop them in the chat and I'll be sure to answer them. But one more thing I would like to do before we go is just do a quick score. So let's create a variable right here called score equals 0. And with this score variable, every single time the bird passes a pipe, we want to set that to true. And how do we know the bird passes a pipe? The pipe goes to the end of the screen. So we can just increase this score variable. I wonder if we can just increase the score variable every single time this function passes. So maybe we can do score plus equals 1, but then we would have to define score global probably. Let's see if this works. It's probably going to crash. I think we have to define score globally. Yeah, I think we have to do a global score. But I don't know if we can do that in a class. We have to increase the score at some point. One thing we can do is, there's several places we can put an increased score at. I'm trying to think which is the best place and which requires the least amount of effort. Could we just global this? Let's see. I haven't tried to do a global in a Python class before. Let's see if we do score plus equals 1. Does that work? Oh, wait, we never know because I don't print out score. Okay, it's not crashing at least. Let's do game over colon let's do string word equals game over space colon space end quote, no space, colon end quote, and then we put in score dot to string. How do I do score to string? It's into screen, and it's different like every language. Into string Python. Oh, it's stir. Stir score, and then stick in the string here. So let's see if that works. 1, 2, die. Must be Unicode or text bytes. Let's do that. Huh. Well, it's on about something. So, oh well. Since we're running low on time, which is I'm under pressure and I don't want to hold you all and hold back the next presenter. We just put game over back here. And let's really quickly just print out the score. So we can see it all. Yeah. Okay, so we can see in the chat that it's increasing. But to display it, you would just use another, what's it called? You would just use the screen built thing that we used before. Just make sure you turn it into a string and everything. And all of that jazz. So I'm going to push this code to GitHub before you all leave. For anyone who has questions on it, we'll be able to just look at the code like that. If you have any last minute questions, feel free to drop them in the chat. And I'll get you all a GitHub repository you could look at. Week accept Flappy Bird. Owner's me public repo. Okay. Let me add this file. Awesome. And commit these changes. Great. Okay. So I'm dropping in the chat. Su Chow, you came late to my stream yesterday too. But anyway, here's my GitHub. You came just in time to receive my GitHub link. So here you go for that one. If you need the code, there's the full code. Any questions on it, feel free to type in Discord on the workshop channel, and I'll answer that. But that's all I have for you all. Say goodbye to Colin with an N, and say goodbye to Kyle, my clickety clackety dragon friend. Adam says time to do a bulk install of software. Lol. I hope your form went good, Adam. Goodbye, everyone. Colin says bye to you all too. Bye. Time for me to finally rest for the first time all week. Bye.